Okay, I hope that everyone is back. Okay, excellent. Okay, now the request which I have received from a lot of students about the topic is errors and uncertainty. I have heard that a lot of you have problem in this topic, isn't it? Yes. Okay, so what I want you to do is that just show me thumbs up or thumbs down if just even a single alphabet is not clear in this topic. Okay, so that I could make things easier for you. Okay. So over here, in order to understand errors, first of all, you should know that error means that something is wrong. Okay, something is not clear, something is not happening proper. This is what errors are. Okay, now in physics, both in IGCSE and A levels, okay, as you guys are from both the levels, okay, remember first of all, to understand these fancy terms such as precision, accuracy, and certainty, you should know that errors are of two types. This is the first thing you should know. Okay, now the people who are taking notes or they are writing something, I just want them to stop for a second and pay attention on what I'm saying. Okay, don't worry, don't worry, everyone. I will post this file, this document. Okay, I will. Okay, so here errors are of two types. Okay, you could say that you will see errors, okay, in instruments, okay, and sometimes you see errors in readings or in values, okay, or in values, you could say, or in numbers, you could say. Okay, as I told you that to measure something, if you connect it just from our previous section, that all the physical quantities, if I have to measure, I need an instrument to measure them, isn't it? So do you think that it is possible that there could be an error in an instrument? Okay, something could go wrong in an instrument. Okay, these type of errors, when something goes wrong inside an instrument, then these type of errors are called as instrumental errors, you could say. Okay, but if you see, okay, let me give you an example. For example, have you seen that sometimes when you go to a bakery or to shop something, they have a weight machine, isn't it? And sometimes, even though there is nothing on this weight machine will be showing you something like 0.1. Okay, yes, the machine is not on zero, correct? Sometimes you see it. Uh-huh. Okay, so this means there is an error. Something is wrong inside the machine. That's why it is not showing zero. Even though we don't have anything on it, it should show zero, but it is showing 0.1. So there is an error. This type of error is an instrumental error, okay? But sometimes you will see that you measured, okay, something. Let's suppose you put bananas over here. I'm just giving you an example, okay? So these are bananas. Never draw bananas like that, okay? So these are bananas. You did them one time and you just noticed that the weight which was coming, it was, you could say 7 kgs. Okay, it's an example again. Next time you just saw it, it was 7.0 kgs. Okay, again. Third time you saw it, it was 7.01 kg. Okay, the next time you saw it, it was 7.02 kg. Now, you took the same bananas, but you measured 4 different times and you get 4 different results. So do you think that there is an error in these values? Okay, so these type of errors, once you see the errors in your readings, in your values, we were doing an experiment and you see an error there, this type of error is called as a reading error or an error inside a reading or error related to numbers, okay? Is this thing clear? Why I'm using different terminologies? Because I know that you are coming from different schools, so maybe you have heard these type of words. Is it clear? So to understand this concept, first of all, you have to understand that errors are of two types. Instrumental errors, okay, something could go wrong with an instrument, or there could be something wrong in readings, okay, in readings or in values. Make sense for everyone? Sure, I will give you 2 minutes to write it. If this thing is clearer, okay, if this thing is clearer, now I am moving on to the very fancy term, which I know that all of you have requested me to teach it. It's precision. Okay, precision. I could see yes from everywhere. Okay, so here I am. Precision. This term, okay, will become easy for you if you understand the above concept that errors are of two types. Is this thing clear? Instruments and reading. Remember, the concept of precision, okay, it is also related to two things, okay, instrument and reading, and the readings which you get, okay? Yes, all the confusions which you are going through, or all the things which are unclear in your mind is this, because you don't understand one thing. What is that one thing? Remember, precision related to instrument is totally different compared to precision related to readings, okay? Both of them have different concept, different ideologies, different terminologies, okay? Why I use these words? This is because that when you search on Google, or when you are just randomly going through all the websites which are present, some of them are good, yes, I agree. But once you go there, you don't know. The students who are coming new to IGCSE and A-levels, they don't know which one to believe, because there you would see different definition of precisions. Why? First of all, keep this thing as clear that precision, okay, once you define precision, okay, you are defining precision in terms of instrument, you will get different definition. You are defining precision in terms of readings, you get different definition. Make sense? Sure? Okay, should I move on? Okay, here you go. So let me define one by one for you. Okay, the first one which I'm going to do is precision. Okay, it is precision. Okay, and instruments. What is this? Okay, precision and instruments. Okay, let me just box it out. Okay, precision and instrument. Precision and instrument means, okay, it is the least, okay. It is the least count, okay? It is the least count of an instrument. A lot of students are saying that we did that definition. Okay, it's the least count of an instrument. Okay, it's the least count of an instrument. What does that mean? It means that when you're talking about precision in instrument, it means that what is the lowest value to which an instrument can measure. This is what precision in instrument is. Okay, precision in instrument means that what is the lowest value to which an instrument can measure. Make sense? So in precision in instrument means that it is the least count. It is the least count of an instrument. Make sense to all of you? Should I move on? Okay, let me move on. Okay, here. Let me give you an example and things gonna become clearer for you. Okay. Do you believe that here, a meter ruler, okay, a meter, okay, I could see that's cracking. Let me just, okay. Okay, here you go. A meter ruler, okay, it's an instrument. Okay, yes, it's an instrument with my ear. Different types of lengths with it, okay. A meter ruler, the lowest value to which a meter ruler can count, it is 0.1 centimeters, isn't it? Okay. Second, a thermometer, okay, the lowest value to which a thermometer can count, it is 1 degree Celsius, isn't it? A protector, okay, some people call it D, it's okay. Okay, protector, the lowest value to which a protector can measure, the least count, will be 1 degree, correct? A stopwatch, okay, a stopwatch, okay, which you will see, it will have a least count of 0.01 seconds, okay? So this is how we define precision in instruments. Remember, precision in instrument is the lowest value to which an instrument can measure. Okay, this is what precision is when we are talking about instruments. Okay, so you might, the people when they search, they might see this definition. Okay, so if I say that what is the precision of meter ruler, you would say, Miss Binte, it's 0.1 centimeter. If I talk about what is the precision of thermometer, you would say 1 Celsius. If I talk about protector, 1 degrees. Okay, so this is precision in instrument. Make sense? Should I move on? Okay, the second thing which we're going to discuss, it is precision. Precision. Okay, and readings. And here are the magic stars. Okay, precision in readings is totally different than precision in instruments. Now, the people, if you have learned the definition of precision, that it is a least count, yes, this definition is correct, but it is only related to precision in instruments. Precision in reading, it have a totally different definition, and let me show you what the definition is. Here you go. Precision in readings means that it is how closely related, okay, two or more, okay, values are to each other. Can you see it? Okay, how closely related two or more values are to each other. This is what precision in readings is. The problem arises when you don't understand that precision, when you define with instruments, it's different. The definition is different. It's least count. Precision reading, it's different. It is how closely related two or more values are to each other. Okay, so let's suppose if you measure something and you get a value of 0.01, okay, centimeter, let's suppose, and you get a value of 0.033 centimeter, okay? How closely they are to each other. This is what when I say that what's the precision in this reading, this means I'm talking about that how closely these two are to each other. Okay, it's not the least count. The biggest mistake you could say, which I have seen in some students, they would say, oh, here their precision is 0.01 because this is the least count. Totally wrong. Biggest mistake you could do. Okay, over here, my students of this merge class, okay, I don't want you to repeat this mistake ever, okay? Because over here, remember that precision in instrument and precision in readings, different. Okay, one more time, just to make things clear to you guys. Remember that errors are of two types, okay? You could see errors in instruments, you could see errors in readings, okay? In the same way, precision, okay, are related to instrument and reading. Precision in instrument means that what is the least count of an instrument? What is the smallest value to which an instrument can count? Precision in reading means that you have different readings, how closely the readings are to each other. This is what precision in reading is. Okay, so instrument and readings, you have to understand that there could be errors in instrument and there could be errors in readings. Okay, sometimes our instrument is, we don't have any problem with instrument, but your readings which you are taking, you have errors in those readings. Okay, so that error is the error in reading. Okay, but precision, error, these two terms are clear to all of you? Okay, yes, I will give you 2 minutes, okay, to sink all the things in. Okay, now the next term, so I talked about errors, I talked about precision. The next term, again, which I have heard from this group, that teacher, we don't understand what is uncertainty. Here we go. Uncertainty, the most easiest. So this is my third thing which I'm teaching you. It is uncertainty. Okay, it is uncertainty. For sure, you will get this PDF. Don't worry, I will upload it. Okay, uncertainty, or I will give to who arranged the class. Okay, yes, Miss Zoe, I will handle that one. Okay. Okay, so uncertainty, what is uncertainty? Again, what is precision? Precision in instrument means the least count. Precision in reading means how closely the values are to each other, to each other, to each other. This thing should be in your mind. Why I'm saying, I will tell you in a second. Okay, now what is uncertainty? Uncertainty, okay, see here. Uncertainty is, okay, is 50%, 50%, okay, of the least count, of the least count. And what was least count of an instrument? It's precision, or you could say it's a 50% of precision. This is what uncertainty is. That's it. That's it, guys. If someone asks you that how to calculate errors or uncertainty, it means that it's a 50% of the least count in instrument. First of all, I'm talking about instruments, okay? Instruments, okay? Yes, you could write it. Okay, uncertainty is 50% out, or you could say half, okay? Half of the least count, 50% of the least count. Now, to make things clear, let me write it. Here you go. So, instrument here, let me just make a short table for you. Okay, so that thing's gonna become easy. Instruments, okay? I will just make one column here, and then I will write their precision. Remember, what is precision of instrument? It means the smallest value to which an instrument can count, and then I will write their uncertainty. Okay, uncertainty. Here you go. Now, and let me draw a small scale here. Okay, here, instrument, let's suppose I'm talking about a meter rule. Okay, a scale, a meter rule. Okay, its precision, the smallest value to which a meter ruler can count is 0.1 centimeter. What is 50%? What is the half of 0.1 centimeter? That's uncertainty, and it is 0.05 centimeters. Okay, now here. Okay, let me write everything, and then I will tell you some rules on uncertainty. The biggest mistake you should avoid in A levels, okay? Here, protector, okay? Precision is 1 degree, correct? Lowest count is 50% of it is 0.5 degrees, okay? Remember, my dear students of IGCSE and A levels, this my lovely merged class, remember, uncertainties are always written in positive and negative signs here like this. Please, okay? So whenever you are writing an uncertainty, it means positive or negative 0.05. It means positive and negative 0.05, okay? Make sense? So our uncertainties are always written like this, okay? Or you could say that whenever you see positive and negative, it means that they're giving you uncertainty, okay? Simple. Is this thing clear? So whenever you see these horrible questions which are making no sense to you, just remember my words that plus and minus, if they are coming together, this means uncertainty is there, okay? And what is uncertainty? Is 50% of the least count. Make sense? Yes, you could say that this is how to calculate uncertainties. It's 50% of least count. Well, there's a detailed topic. I'm coming to it, okay? But just for now. Okay, should I move on? All of you? Okay. Sure. Okay. Now the next topic which I have to discuss. Okay, so I discussed about errors again and again. I'm repeating things so that your mind get used to all of these words. Okay, errors. There are two types of errors. Could we seen in instruments? Error could be seen in readings. Precision is related to instruments and in readings. In instruments, precision is least count of any instrument. In readings, precision is how closely two values are to each other, okay? Then we talked about uncertainty. Uncertainty is always 50% of the least count, okay? Or you could say 50% of precision, okay? And we always write uncertainty in positive and negatives, okay? The other term is, which is related to this topic, it is, here you go, accuracy. So this is fourth topic, accuracy. What is accuracy? Accuracy is, now over here again, students get confused because they never, well, not never, most of the time students don't listen to words carefully. Precision in reading was that how closely values are to each other. So you get a set of values after doing an experiment. How closely these values are to each other, this is what precision is. Accuracy. Accuracy is, please write it. Accuracy is how close a measured value, okay, value is to actual value, please, actual, it's actual. Don't ever confuse accuracy with precision in readings. Accuracy is how close a measured value is to actual value. Let's suppose you did an experiment, okay, you knew that actual value should be 2 centimeters. But once you did an experiment, you got, let's suppose, 2.03 centimeters. Okay, so how close this is to this actual one, this is what accuracy is. Make sense? Okay, so accuracy is how close a measured value is to actual value. Okay, and remember that I taught that precision is for instruments and for reading, but accuracy is always for readings, just for readings. Okay, we don't have accuracy for instruments. We just have accuracy for readings. Okay, remember, we just have accuracy for experiments. We just have accuracy for readings. Please make sure that you know this difference. Okay, so over here, so can I say that instruments, so here's my statement, please, instruments, okay, have precision, okay, but no accuracy. This is the biggest statement here today. Oh, okay. Here, this one. Okay, that instruments have precision but no accuracy. Okay, so whenever we talk about precisions and accuracy concept, remember that we cannot compare, or we cannot tell how close an instrument was to the actual. No, okay, we cannot believe on this concept. But remember that instruments have precisions. Okay, we can find, I told you that precision related to instruments, the least count, but no accuracy. Okay, make sense? Should I move on? Okay, now after coming back, I hope that you got an energy to discuss this topic more. So again, just for a quick revision, that errors are present in both instruments and in readings. Okay, precision, when we are talking about precision related to instruments, it means the least count of something. In readings, it means how close the values are to each other. Accuracy is how close a measured value is to actual value. Okay, so over here, I told you a statement which says that instruments, okay, have precision, okay, but no accuracy. Precision, but no accuracy. This was the statement which I wrote it before, correct? This was the statement. But the thing is, why? This is the thing, why? And the answer lies here. Let's suppose, okay, so accuracy means that how close a measured value is to the actual value. Okay, measured value is to the actual value. Okay, now, and precision, and the precision is the least count. Okay, now instruments have precision. So this means if I have a meter ruler, okay, and its precision, its least count, okay, its precision was 0.1 centimeters, correct? This was the precision of meter ruler, correct? Okay, now what happened that, as you know, the time passed by, we modified our devices, okay, and then to measure certain lengths, certain distances, certain amount of length, you could say, there were more precise instrument, and the name of that instrument was vernier calipers, correct? Vernier calipers. Okay, and in vernier caliper, the precision, the least count, okay, the smallest count to which a vernier caliper can measure it is 0.01 centimeters, okay? The least count of an instrument changes, isn't it? Okay, but we are just measuring the length, isn't it? Now then, what happened that micrometers came into being? Okay, micrometers came into being, and now the precision becomes 0.001 centimeters. Again, it is. So every time we are growing into our technological world, what happened that the precision is increasing. So do you think that we will get a proper true value to which we can compare things out for length? No. So this is why precision, instruments just have precision but no accuracy, okay? So precision is increasing, okay, here. Is this thing clear? If someone asks you, well, this was just out of the course, if someone just asked me that why it is. Okay. Over here. Okay, now here. I just want to relate one thing, a biggest mistake again, which many students make, okay? So here you go. Okay, let me just increase the space here. Okay. The mistake is this. Let's suppose over here, okay, I have given you, here's a meter ruler, okay, and I told to one of my students to measure a length of something, and let's suppose the length which you measured, okay, it was here on meter ruler, it was 3 centimeters here, and it was 5 centimeters here. Okay, so the length of this green thing, okay, the green thing, the length will you said, so you just said 5 minus 3, and it is 2 centimeters. If you write answer like this, in A levels, a big no and big 0. Why? Because you have to understand the concept of precision. Remember the least count to which a meter ruler can measure is 0.1 centimeter. So it's a 2 decimal scientific figures, okay? Remember this concept of scientific figures, highly important. Even, okay, in IGCSE, if an examiner is there who knows the concept, he will just see your answer and he will understand how much you know, where your concept lies. Okay, so if you were measuring with meter ruler, remember that you have to give your answer in 2 decimal places, okay, or 2 scientific figures. So your answer should be 2.0 centimeter. Then this is correct. Why? Because the least count of meter rule is in that figure, okay? If you are measuring from micrometers, okay, so then you have to write your value 2 point something. Okay, now some students I have seen, okay, they will see, oh, Miss Binte said, yes, we have to be super precise, super accurate, super this. What they're going to write? Yes, we should write 2.00. Again, a blunder mistake. Why? Because see, now you have 2. So which instrument is this referring to? It is referring to a vernier calipers. Are you measuring from vernier calipers? Then no, you are just measuring from meter ruler. So you have to try to relate, okay? Try to relate with precision, okay? The reading should be in the same decimal places the way it was in precision. Your answer should be in same decimal places the way it is in precision. Is this thing clear? Because we teachers can judge you on this, okay? If I'm teaching physics anywhere, I will judge easily that either the concepts are clear in someone's mind or not. Okay, so if you are taking a reading from vernier calipers and someone just gave me answer, okay, let's suppose if someone gave me the answer here and they calculated from vernier calipers and they gave me answer of 2.0 centimeter, a complete cross, 0 score. Why? Because you are calculating with vernier calipers. Why your answer is with 2 decimal places? Your answer should be 2.01 or 2.000. Okay, so this is the case. You have to understand these things. These are some technical things, okay? So in today's concept, okay, we learned about errors, we learned about different terms, uncertainty, we learned about accuracy, the mistakes which students make, okay? These are the concepts. I hope that this is clear to all of you. Now, let me come to your questions, please. Yes, please go ahead. So lastly, we discussed about precision and accuracy. Okay, now we're going to discuss how the question's going to appear in exams related to graph, precision, and accuracy. Here, accuracy is how closely our measured value is to true value again. And precision is that how closely the values are which I obtained after experiment, okay? In graphs, what is accuracy? In graph, it simply means that is my true value coming in reading or no? Is my true value coming in reading? Okay. Then that graph is called as an accurate graph. Okay. Now, to make things easier for you, let me draw two graphs in front of you, and then I will ask you that which graph is accurate and which is precise. Okay. So over here, so what did I do? I did an experiment, okay, and I obtained some values, and I will just plot a graph on this, and on y-axis, okay, I just write that number of times reading appear, and on x-axis, I will write my measured values, all my measured values, okay, here, my measured values. My measured values in both the graphs, okay? So this is my graph A, you could say, and this is my graph B. Now in graph A, after plotting the plot which I get, the shape of the graph, it looked like this, okay? And in graph B, the shape looked like that, okay? Let's suppose that my true value, okay, my true value lies somewhere here in the middle. This is my true value, okay? My true value lies here. True values lie here in the middle somewhere in both the graphs, okay? Now, can you please tell me that are these both graphs accurate? Yes, isn't it? Why? Is my true value coming in a reading? Okay, so these are my all readings, okay? Is my true value coming in the reading? Yes, it is coming in the reading. So graph A is an accurate graph. Can I say? Yes, so graph A is an accurate graph. It's an accurate graph. How about graph B? Is my true value coming in a reading? Yes, it is coming in a reading. So is this an accurate graph? Yes, it is an accurate graph. Graph B is an accurate graph. Okay, so my true value is in the reading. Okay, but which graph is more precise? Now to see this, I have to take some values. I will see how closely related the values are. Over here, if I take one value here, okay, and one value here, okay, so I would see that how closely, precision is how closely, so this is the distance. Over here, if I take two values here and two values here, this is the distance, correct? So in which graph the values are more closely related? Graph A. So this means graph A is more precise. More precise. Can you see over here? It's a long distance. Over here, the values, okay, the graph, the overall graph, if you see here, this one, short distance values are more closely related, but over here, long distance, okay, more far apart. Okay, so this is more precise than this one. Make sense? Now, which graph is not accurate? This should be the question. If you get an exam, which graph will be not accurate? Here, I will draw one graph in front of you to show that which is not accurate, but it is precise. See here. So let's suppose I draw a graph here. In the same way, these are the number of times I measured, and these are my measured values, okay? And the graph, let's suppose my true values lies here. Okay, my true value lie here, and the shape of my graph is, and the readings which I calculated, it was here. Is this graph accurate? So this is graph C, which I'm drawing. Is this graph accurate? No, because my true value is not coming in the reading. No graph. Okay, so it's not accurate. It's not accurate. Okay, but over here, is this graph precise? Yes. If you see all the measured values here, the distance is very less. Okay, so they are very closely related. So it is very precise. Okay, so can you see sometimes the readings, okay, the graph tell you that a thing could be very precise, but it could not be accurate because the true value is not present in the readings, okay? The true value is not in the reading. This is the concept of graph, okay? So can you see that once you change the things, the definitions will change a little bit, but all of them are correct, okay? So far, we studied that precision is readings, how closely the readings are to each other. Okay, so this is precision. You took a lot of readings, you plot it here. Okay, so let's suppose this is your one reading, correct? This was your other reading, correct? And you saw that how closely related they are. If they are more closely, this means it's a very precise graph. Okay, such as in graph C. If you see here, readings are very close. The numbers are really close, so it's a more precise one. But accuracy is how close a measured value is to true value. But how could I know that what is the measured value, what's the true value? But if you have a graph, you just have to see that is your true value. If they give you that this was your true value, is this value coming in under your readings, inside your reading, under your graph, then it's an accurate graph. Make sense? So this was graph and errors, how you have to look them.